Welcome to The Explainer. So today we're diving into a really radical theory about a hidden layer of reality, a fundamental law that could, just maybe, connect everything from the neurons firing in your brain to the most distant galaxies in the cosmos. I mean, think about it for a second. A thought, a star, and an atom. On a surface, what do they have in common? Pretty much nothing, right? They all seem to exist in their own separate worlds, playing by totally different rules. A thought is just this fleeting biological spark. A star, a gigantic nuclear furnace. And an atom is, well, a weird cloud of quantum probability. But what if there's a thread tying them all together?
Okay, let's start small. Or, inside our own heads. The brain isn't just a random blob of cells. It's this unbelievably complex network with trillions of connections creating the very fabric of our thoughts. It might look like total chaos, but it's actually a highly structured system, and it all springs from really simple electrical signals.
Now, let's zoom all the way out, to the biggest scale imaginable. The universe isn't just a uniform soup of galaxies sprinkled around randomly. No way. It's organized. We see this vast filament-like structure that people call the cosmic web. These huge clusters of galaxies where the filaments cross, and then these massive empty voids in between. So again, we're seeing this spontaneous, large-scale order emerge from where? And then, if we go all the way to the bottom, down to the realm of the super, super small, things just get bizarre. Quantum particles can be linked or entangled across huge distances, and their states are somehow mysteriously correlated. They don't act like separate little bits of stuff. They act like they're parts of an interconnected, structured system.
So we've got this ordered structure showing up at the neural level, the cosmic level, and the quantum level. Is that all just one massive coincidence? Or could it be the signature of some deeper, undiscovered law of nature? Well, this is where a really wild new theory comes into play, the intent field.
The theory proposes the existence of something called the intent field. Now, this isn't a field of energy or matter like gravity or electromagnetism. It's something brand new, a field that works on raw information, actively arranging it, shaping it into the complex, stable systems we see everywhere, from our brains to entire galaxies.
And at the core of it all is this really elegant little principle. It suggests that intent isn't just a human feeling. It's a real, measurable physical quantity. It's defined as how efficiently raw information is turned into ordered structure. You can think of it like a cosmic architect. The better it is at turning a pile of bricks into a house, the higher the intent.
Okay, so here's the deal. If this theory is for real, if it actually holds any water, we should be able to see its mathematical fingerprint, this specific pattern of organization, absolutely everywhere we look. So, check this out. In a simulation of a brain, the connections between neurons aren't random at all. If you look at their strength, what they call their weights, you see that most of them cluster right in a specific middle range. They're avoiding the extremes. That's not a coincidence. That's the signature of an organizing principle at work.
And this is where it gets crazy. We see that same pattern showing up in deep space. This data lines up the theory's intent density with where we actually find matter. And the result is pretty stunning. Exactly where the theory predicts the field is strongest, that's where we find the centers of galaxies. And where it's weakest, we find those big empty voids. It's almost like the field is laying down a blueprint for the universe to build on.
And unbelievably, the pattern pops up again, even at the quantum scale. This matrix here shows the correlations between different quantum states. It's not just a random mess of numbers. You can see it's a structured relationship that looks an awful lot like what we just saw in brains and in galaxies. 3 completely different scales, all sharing one common signature.
Okay, so seeing patterns is one thing, but proving that one thing causes another, that's a whole different ballgame. So how in the world could you possibly test a theory this massive? Well, you build a universe in a box.
Researchers developed this amazing open-source simulation package they call IntentSim.
It's basically a digital laboratory that lets you create model universes from the ground up and then test the predictions of the intent field theory. And get this, anyone can download it and run the experiments themselves.
And here's a little peek under the hood. Using these really simple configuration files, a researcher can basically set the laws of physics for their own little digital cosmos. They can tune a dial for intense strength, hit go, and then just watch to see what kind of universe emerges.
This simulation then spits out these enormous data sets, all meticulously organized so you can compare the quantum, biological, and cosmological results right next to each other. It really is the ultimate tool for hunting down that universal signature across every single scale. Now, this isn't just some abstract scientific puzzle. The principles they're discovering in these simulations, they're actually being turned into real-world technology. We're moving from the digital world straight into the physical one.
So we're making this huge leap from the virtual to the physical. What was once just an abstract theory being tested inside a computer is now becoming a concrete, applicable principle for building brand new devices. Devices that can interact with and maybe even manipulate this fundamental field. Take this thing, for example, the harmonic bloom generator. It's a real device, and it's designed to literally ping the intent field. It uses a combination of incredibly precise timing, complex waveforms, and specialized optics to create these resonance patterns. In essence, it's learning to speak the native language of the field itself. And the potential applications here are just profound. Imagine quantum processors that are actually stable, or systems that can literally guide how neurons grow using just light. Or maybe the most transformative of all, a completely new kind of brain-computer interface. And here's why that really matters. A BCI based on this theory wouldn't just be reading your brainwaves, it could decode the intent behind them. It could capture a thought, figure out the goal, and then translate that directly into controlling a system. You're talking about a direct feedback loop between the mind and a machine.
So, where does all this leave us? We've journeyed from a pretty wild theoretical puzzle all the way to technology that sounds like it's straight out of science fiction. What we're really looking at is a fundamental link between information itself and the very structure of our reality. The theory gives us this profound new equation, and it's not just for physics, but for action itself. It's suggesting that when resonance, the right kind of pattern, interacts with meaning, the right kind of information, what you get is organized, aligned behavior. It's like discovering the physics of purpose. This is way more than just a new chapter in a science textbook. It's a total reevaluation of our place in the universe. It suggests that our intention isn't just a feeling stuck in our heads, it might actually be a primary force of nature. And if our intent truly shapes reality, what on earth will we choose to create with it?